We're now going to do a unit on density, and it must be important for TRO to devote a whole section to this topic. And it turns out that it is actually hard for students to really have a good understanding of density because it relates to ratios, which is always a troublesome math area. So let's go through it again. I know you've done density in the past, but let's just practice it some more so that we're more and more comfortable with the idea that density talks about the mass that's in a particular volume of a material. So we could look at a bike, and the more expensive bikes have very low densities. So we're saying people would pay $3,000 for a titanium bike. Titanium has a density of 4.5 grams per cubic centimeter. Cubic centimeter is the volume, right? And that's the mass in a given volume. That's a lot less dense than iron, which has a density of 7.86 grams per cubic centimeter. So here's the formula for density. I know you know this. Density is mass over volume. We're really talking about having a good sense for what that means. Let's do a couple problems. If you were told that a sample of liquid has a volume of 22.5 milliliters and a mass of 27.2 grams, how would you find its density? So we write our formula. We say density is mass over volume. What were you given? You were given the mass. It's 27.2 grams. And you were given the volume. Milliliters is the volume. 22.5 mils. So you take 27.2 divided by 22.5 and you get 1.2 grams per mil. And that doesn't simplify. The units of grams per milliliter are the correct units for density. Let's do it again. For a liquid substance that has a density of 1.32 grams per cubic centimeter, what volume should be measured to deliver a mass of 68.4 grams? Density is mass per volume. What were we given? We were given D and we were given M. We're solving for V. It's your preference on how you want to do this. I like to rearrange the equation before I substitute. So rearranging this, it becomes this. These guys flip places, right? Because you could see this as ratios, and we do the crisscross effect and then divide through by the other side. There are a couple math moves in there, algebra moves. But the ratio becomes this. Put in our numbers. 68.4 grams divided by 1.32 grams per cubic centimeter. And you can see how grams will cancel and the cubic centimeters comes up on the top, and you end up getting 51.8 cubic centimeters. Let me just mention, whenever I ask students to find the unknown in the denominator, 40% of the students will make an algebra mistake. So watch out for that. Here's another style problem that you'll have on Mastering Chemistry. A new penny has a mass of 2.49 grams and a volume of 0.349 cubic centimeters. Is this penny pure copper? Here's a table of densities. Density is an inherent characteristic of the material. We see copper right here. It has a density of 8.96 grams per cubic centimeter. So let's calculate its density and we'll compare it. So we actually do a lab like this. And I give you an unknown cylinder and you have to figure out what kind of metal it's composed of. We do it based on its density value. We compare to a table like this. When you take 2.49 grams and divide by that, you get 7.13 grams per mil. That is not very close to 8.96. We'll see later, we actually have a 10% rule that we use. We would say, is this within 10% of 8.96? It is not. So we would say that no, it is not made of copper. You might actually say iron looks like a better choice than copper. Let's go back to the titanium bicycle idea. The titanium bicycle frame contains the same amount of titanium as a cube, where each side is 6.8 centimeters. So this is our cube right here, 6.8 centimeters. What is the mass of this? or the volume of this. So if we cube 6.8, we come up with a volume of 314.4 cubic centimeters. That's its volume. Use the density of titanium to calculate this mass in kilograms. Well, density is m over v, so m would be d times v is density of titanium, 4.5 grams per cubic centimeter, grams, times 314.4 cubic centimeters. You come up with a mass of 1.4 kilograms. What would be the mass of a similar frame composed of iron? So the only thing that's going to change is this d value, right? So in place of 4.5, we are going to put 7.86. 7.86 right there. And when we do that, we get a mass of 2.5 kilograms. So that's a substantially different mass. So that's why people pay more, is to have the strength of titanium, but not the mass. Let's do one final density problem. Ethylene glycol is the official name of antifreeze that you put in your car. It's more dense than water. It has a density of 1.11 grams per cubic centimeter. Do you know the density of water? The density of water is 1. It sets the scale. It's 1 gram per mil, or 1 gram per cubic centimeter. You do remember, I hope, 1 milliliter equals 1 cubic centimeter. This is that handy conversion that I ask you to remember. Well, you're asked, what's the mass of 387 milliliters of this liquid? 387 milliliters is 387 cubic centimeters. Basically, we're being given V. So, density is mass over volume. What I'm going for in this problem is mass. I'm given density. It's I'm going to move over here, 1.11 grams per cubic centimeter. I'm looking for m. The V is 387 cubic centimeters. If you multiply 1.11 times 387, you'll get 429.6 grams. I just reported that with 4 sig figs. How many sig figs do I get for multiplication? I have 3 sig figs here and 3 here, so I must report this to 3. So how would I report this to 3 sig figs? It would be 430. But 430 doesn't necessarily have 3 sig figs. We would say that has 2 sig figs. So I put a decimal point here to count the 0. So I'm reporting the answer in correct sig figs. Next problem. What is the volume of 3.47 kilograms of this liquid? Now it's that classic problem I told you that trips up some students in their algebra. If I ask you for the unknown in the denominator, watch out that you do your rearrangements correctly. I'm looking for V. I know M. Density is 1.11 grams per cubic centimeter. M is 3,460 grams. I have to get to grams, so I have like units. V is what I'm looking for. So V is 3460 divided by 1.11, and that is 3120 milliliters, or, to correct sig figs, 3.12 liters, answering in liters. So it's 3120. I get 3 sig figs because of 3 and 3 for division, and I report it as 3.12 liters. That's it for density. You'll get more practice in mastering chemistry.
Attempting to ride in a place that nobody has is exhilarating and scary. Every movement is critical, knowing that one small mistake could literally be fatal. I managed to catch myself before I went off the second cliff, and then when I looked down, I was just like, oh, there's my bike, tomahawking me down 200 feet. My name is Darren Bearcloth, and I'm a professional mountain bike freerider. No other mountain biker has ever been to Cameron to try to ride these lines. It's looking like it's pretty dang awesome. Pretty fired up right now. From a distance, everything looks awesome. When you stand here, this place presents a whole new set of challenges. Marbly rocks, wind-packed dirt, 6-inch spines that close out to almost nothing. It's going to be pretty difficult to get her down there. Dropping in after almost dying is rowdy. Your hands are shaking, your adrenaline peaking. It's just scary.
5, 4, 3, 2, 1, roll.
Everything from riding down the hill to putting pressure on the pedals, it all relates to movement. It just turns into something where you're just like, you don't even think about it. You just do it. This environment is definitely one of the most challenging zones I've ever tried to ride. What looks good on the surface, it can be way different when your tires are in the dirt. From practice to preparation, when you let go of the brakes, every move counts.